Hi, we're Pung Pung Physics, and this is our DP2 presentation. I'm Anuj Roy, and my group mates are Brett Pomerantz and Trevor New. Today we'd like to talk about how far we've come so far in our project, and the progress that we've made so far since our last report. We'd also like to talk about some patents that we've looked into that we believe can be incorporated into our design to create a more sustainable design that's more interactive and also more that also incorporates the ideas of basic fundamental physics and principles into our design. We'd also like to talk about how we chose the stations that we did and what we actually would like to choose for our final design and how we went about choosing each of these. We'd also like to talk about the possible sources of error that we found in our designs for each station and which parts that we believe could possibly run into errors and what we can do to amend these issues. Finally, we'd like to talk about the economic analysis and the investment costs that we believe we need in order to create our actual Rube Goldberg design and how much we believe it can actually return after a 3-year period. So this is our updated Gantt chart, and it shows that we've completed tasks A through E, the identification of customer needs, up until the concept testing. We have now moved on to step F, which is the actual product architecture section, in which we are now constructing our final design and the parts that we actually believe will be our final model and the one that we'd like to demonstrate in the end. This is our DSM matrix showing the dependency of each of our tasks and what we believe will be necessary to be completed beforehand and other tasks in general. As I stated earlier, tasks A through E have already been completed and we are now in product architecture step F. But tasks H through K will be coupled tasks, meaning they need to be completed simultaneously. This means that the design for manufacture, economic analysis, modifications to design, and prototyping must all be completed simultaneously so that they are accurate, specifically so that the economic analysis can be an accurate comparison and analysis of our design. I'd also like to talk about the 5 patents that we looked into and how we believe they can be incorporated into our design. In the first patent, it talks about a possible way that we can incorporate our design outside of the classroom, specifically how a 3D model can be projected onto a surface so that students can interact with the possible Rube Goldberg machine that we want to design outside of the classroom and how they can use it to continue to grow outside of just the demonstration. In patents 2 through 5, we actually talk about how the possible ideas in these patents could be incorporated into our into our Rube Goldberg machine. Specifically, in Station 2 and Station 4, we like to talk about how a projection model can be used to show projectile motion of the ping pong ball through ramps. And in Station 2, in Patent 2, it talks about how there's a possible that we could trigger the force sensor so that the spring in Station 2 of our design actually activates upon impact, as we planned. In general, these patents have provided an intellectual intellectual component to our design that we believe can be very helpful in creating a more complete Rube Goldberg machine that incorporates lots of ideas that we are looking to demonstrate outside and inside of the classroom. Brett will now talk about the concept generation and testing of our models, as well as the FMEA models that we came up with and what we plan to do from there.
Hello. So for our models, we had each teammate come up with 2, 3, or 4 design for each station. This was a way so that we can all get many different ideas and possibly get there's a light bulb in our head saying, oh, this is a good idea, we can work on it this way. And then we used our concept generation, concept selection, concept screening tables, as well as the customer needs to decide on which ones we'll move forward on, and we decided on these 3. This is our Station 1 design. It is it's a ramp that has an adjustable angle to it, so that the children will be able to decide which angle they need to have the ramp at to get it to go a certain distance. At the end, it will bounce off of this wall and go off to the side, which will also trigger a mini Rube Goldberg-like thing on top, like dominoes, just for some more aesthetic pleasure and just to hide the Rube Goldberg effect of it. For Station 2, after the ball has gone off the horizontal part of Station 1, it will go to a ramp, which will lead into a spring, and the spring will have something on top that'll be compressed down. We'll use, like Anush said, some force sensors, the spring sensors, to determine when the spring will be launched, and it will launch the ball upwards while keeping its horizontal momentum, and it will be gaining vertical momentum while also gaining some potential energy. This will be interactive since the students will be able to decide on how far down the spring needs to be compressed to gain the correct amount of height. For station 3, this is mainly to show acceleration. Down here, as you can see, we'll have 2 spinning wheels. However, that was the original plan. We decided that it was too difficult to have 2 different spinning wheels, so we're going to make one just on top here. That's going to be spinning. As the ball reaches it, it'll accelerate that towards the ramp, and then we'll launch that up to the other ramp, which will both gain some momentum and some potential energy. This is going to be interactive in 2 ways, since we'll be able to adjust both the speed of the wheel and the distance between the 2 ramps. So for our FMEA, or failure mode and effect analysis, this is one of the most important parts of the design process. It is basically just a chart that shows us what kind of failures will happen, how they'll happen, how likely they are to happen, how severe it'll be, and ways that we can stop them from happening. Over here to the right is an example of one, which the RPN down here is just the product of the severity, occurrence, and detection. And the higher the RPN, the more worried you have to be about that. So like down here, 32, since the detection for that is very high. 2 means that we can detect it very well. It's not as much of a worry than part 1. A main way to reduce these risks is getting experts to do the machining and buying higher quality materials that will last longer. And now my other teammate Trevor will do the economic analysis and the conclusion.
Hello. So now we'll discuss the economic analysis, particularly our investment proposal for our project. Our team decided on an initial investment of $500,000 for our entire project, and this would be an investment given to us right at the very start of the project. The importance of this investment is that the project cannot go anywhere without any kind of monetary support. So, and we believe that $500,000 is plenty of money to get us through the design, the manufacturing, and everything that goes into this product. The length that this loan will carry out for our team is 3 years, and the team decided that it will pay back this loan at a quarterly rate among those 3 years. So all in all, it would be 12 different payments throughout the 3 years. We have a yearly interest rate of 14%, broken down into monthly, that it comes out to be 1.16%. Using the amount of money that we were initially given at the very start and this interest rate, we calculated that the amount of money that we'll have to pay back to VTEPS sorry about that. The amount of money that we'll have to pay back to VTEPS per quarter is $874,074.74. And at the end of the 3 years, VTEPS will get a return of $538,496.88, which is $38,496.88 more than they originally gave us. So they will be making some money on this investment. So in conclusion, this section of the design process for us is included the concept generation and selection for our stations. This is all that was based off of our initial work in DP1. So we used customer needs and the research that we did to come up with designs that we thought would be the best for our BRG. Along with this in this DP2 phase, we researched patents that we can either use for our design or won't be able to use because there are some that is already taken. But it's very important to get some ideas of what is already out there. Like I said, this phase was mainly coming up with and choosing designs amongst our team, so we could have the best design moving forward into our final phase. That FMEA was another important part of this design as well, or phase as well, so we could know the risks and failure points for each of our designs moving into our final phase. The economic analysis and investment part of this, the design phase as well, is very important because without this analysis, we would not be able to have any kind of money moving into our final phase to use into creating our BRG or manufacturer or any of that. In conclusion, the team has made great progress. We are on track and we are looking forward to moving into our final design phase and creating our final product. Thank you.